Hey guys, how are you all? I hope all of you doing well. So today we are going to start the new video, new lesson, that is aldehyde ketone carboxylic acid. So after the studying lesson, what are the things you are able to? The common name and IUPAC name of aldehyde ketone carboxylic acid, write the structure compound containing functional group, namely carbonyl and carboxyl group. Then describe the important method of preparation of aldehyde ketone carboxylic acid. Then correlate their physical property and chemical property with what their structure. Okay, so explain the mechanism of few selected reaction. We will discuss the mechanism of your aldehyde condensation, condenser reaction. We have discussed later. Okay, next we go for the understand various factors affecting the acidity and carboxylic acid. Okay, acidity of carboxylic acid, there is electron withdrawing group, there is electron withdrawing group, electron releasing group, it is there, we will discuss there. Okay, in previous unit you have studied organic compound with functional group containing the carbon oxygen single bond. Carbon oxygen single bond. If I am taking the alcohol, so carbon connected with OH, right? This is single bond, right? But in case of here, if you take the carbonyl compound, see double bond O, right? Okay, so here it is a double bond. Okay, so we will study about the compound containing the carbon oxygen double bond called carbonyl group. So which one of the most important functional group of the organic chemistry? Yes. Next, okay, look here, in aldehyde the carbonyl group is bonded to an carbon and hydrogen. Okay, so carbonyl carbon is bonded with hydrogen. Okay, that is your aldehyde. Okay, if it carbon, that is ketone. Okay, it is bonded with two carbon atom. Okay, your carbonyl carbon in which the carbonyl group is bonded to oxygen. Okay, carbonyl compound is bonded with your oxygen are known as carboxylic acid. Okay, their derivatives esters and anhydrides. Okay, while the compounds were, okay, the carbon is attached with nitrogen, okay, to halogen called amide. Okay, so alkyl halide respectively, the general formula of this classes of compound. So here your carbonyl group is bonded with your hydrogen, your carbonyl group is bonded with two carbon, so this is aldehyde, this is ketone. Your carbonyl group is bonded with OH, so this is carboxylic acid. Okay, so in case of this one, your carbonyl group is bonded with halide, so acyl halide. Your carbonyl group, okay, between there is oxygen is there. Okay, if you are taking the two acid, from that if you are removing the water, then we will call it as a acidic anhydride, right? So when it comes to the compounds of the aldehyde ketone and carboxylic acid, okay, so here there is a look here, the carbonyl group is bonded with, your carbonyl group is bonded with OR, so this is ester. Your carbonyl group is bonded with NH2, this is your amide. Okay, so aldehyde ketone carboxylic acid widespread in plant and animal kingdom. They play important role in the biochemical process. Okay, so they add the fragrance and flower to the your nature. For example, vanillin. Okay, so vanilla beans. Okay, salicylaldehyde, meadow sweet, and the cinnamaldehyde, cinnamon. Okay, have very pleasant fragrance. Okay, so when it comes to, they are used in many food product. Okay, the pharmaceutical flowers. Then some of these families manufactured, okay, for uses of solvent. So for preparing material like adhesive, plant and resins, perfumes and plastics and fabrics. Okay, then there is a nomenclature. Common nomenclature is there, IUPAC nomenclature is there. So when it comes to common nomenclature, okay, so it is the name from the your Latin and Greek term. Okay, so mainly the source of acid and aldehyde. Okay, your common name is source of aldehyde. So what is the thing which is more important is there is a your functional group. This is your functional group, right? Near to the carbon is alpha, then near to the beta, this is gamma. Okay, this you need to understand in case of the common name. Okay, so name is not that much important. Okay, but your IUPAC name system is more important. In case of IUPAC name system, what is the things I need to know, sir? Say for example, look here, I take the aldehyde, I take the ketone, I take the carboxylic acid. Okay, so here there is a prefix name, here there is a suffix name. Okay, your prefix, okay, for aldehyde, we can say oxo, okay, or formyl, oxo or formyl. In case of ketone, oxo is the prefix group, the carboxylic acid not having any prefix name, okay. When it comes to suffix name, it is Al, it is one, it is oic acid. This is more important, okay. In this case, your carboxylic acid is more preferable functional group than your aldehyde, than your ketone, okay. This thing you have to understand, okay. So we start next. So we will start naming of your molecule, okay. Look here, this is 2 carbon is there, so ethanol, so this is aldehyde, it end with Al. In case of here, so this is pentanol, right? First we will give the number in order to give the preference to the your functional group. So 1 2 3 4 5 6 7, okay. So this is heptanol. In the third position methyl is there, in second position bromine is there, okay. Next we will start with one more compound. So this is your functional group, we have to give least possible number to this. So 3-methyl cyclopentanol, okay. In case of this one, this is cyclohexyl, right? This name is carbaldehyde, cyclohexane carbaldehyde. In case of this one, 1 2 3 4 5, so pent 2-enol, okay. When it comes to this one, this is your ketone, okay. So propanone, right? So in that there is a presence of phenyl. So 1 2 3, so first position phenyl is there, so propane 1 mole, okay. Clear? We start with some of the name which is given in your table, okay. So this is methanol, this is ethanol, then the next one is your CHO, CH3, CH3, right? So 1 2 3, okay. 2-methyl propanol, okay. 2-methyl propanol. We will start with another one molecule. This is your functional group, right? 1 2 3, okay. But we can go this way, so at the time your substituent get the least possible number. So 3-methyl cyclohexyl carbaldehyde, okay. Then your next molecule, let's give the number. So 1 2 3 4 5 6 7 8 9, okay. One by one I will do it. So here let's take CH3, CHO, CH3, CHO, okay. Clear? So 1, so this is CHO, right? So 1 2 3, so 2-methoxy propanol, okay. Understand? The next one is we can, by seeing itself we can say 1 2 3, okay. So 2-ene is there, right? So propane 2-ene. Then this is benzene, right? In benzene, first and second position there is a aldehyde group is there. So we know that, right? If it more than if it 2 or more same functional group is there, at the time hydrocarbon name, if it methane is there, if it ethane is there, okay, at the time E should not be removed, remain as same. So in case of benzene, so benzene E is remain, so benzene 1, 2 dicarbaldehyde. In case of this one, so third position bromine is there, right? So 3-bromo benzene carbaldehyde. Again, one more thing I want to explain here. This is, we can say benzene carbaldehyde or we can say benzaldehyde, okay. Both are accepted by your IUPAC, okay. Next, when it comes to the your ketone, so we have to give number. So 1 2 3 4 5, second position 1 is there, so pent 2-1. Then this molecule I will write it, okay. Look here, CH3, then your C double bond O, then CH, then CH3, then CH3. So 1 2 3 4 5, okay. So in second and fourth position there is a methyl is there, so 2,4 dimethyl, pent, third position 1 is there, 3,1, okay. So 2,4 dimethyl pent 3,1. Next, when it start with this one, so 1 2, okay. So 2-methyl cyclohexanol. The last molecule I will explain to you is this one, okay. The last molecule is, look here, so there is a double bond is here, right? So CH3, CH3, here double bond is there, then CH, then C double bond O, CH3, clear? So this is your double bond is more double bond O, that is your ketone is more preferable, so we have to give the in the way of least possible number to the your keto group. Okay, so 3, 4, 5. Okay, so in second position one is there, then fourth position methyl is there, so we can say 4 methyl, your parent name is pent. Okay, 3 in 2 1. Okay, so 4 methyl pent 3 in 2 1. So next, look here, this is very important. Okay, this is very important. Okay, structure of your carbonyl group, very important, very important. Okay, so the carbonyl carbon atom sp2 hybridized and form the 3 sigma bond, and the fourth valence electron carbon remain in the p orbital, form the pi bond. Okay, so oxygen by overlap with p orbital of oxygen. In addition, the oxygen atom also has the 2 non-bonding electron pairs. Okay, thus carbonyl carbon and 3 atom attached to it lie in the same plane. Okay, so the electron cloud just present above and below the plane. If I am taking the your carbonyl group, so here 1, 2, 3. Okay, 3 sigma bond is there, 1 pi bond is there. Yeah. Then your bond angle going to be, your hybridization going to be sp2, so trigonal planar. So trigonal planar, what is the bond angle? 120 degree. Okay, so we know that, right, the carbon and the oxygen is more electronegative compared to carbon, so electron will move towards the oxygen, so it become a minus, it become a positive and negative. Okay, so the carbon oxygen double bond is polarized due to high electronegativity of oxygen related to carbon, hence the carbon is electrophile. Okay, so this is electrophile, so Lewis acid, electrophile, Lewis acid. But in case of oxygen, this is nucleophilic and Lewis base, nucleophilic Lewis base. Okay, so the carbonyl compound have substantial dipole moment and are plane polar than ether. Okay, right, so high polarity of carbonyl group explained on the basis of resonance involving the 1 and 2. Okay, A and B. Okay, so then there is a structure they are asking. Okay, so I will do one by one. So first they are saying propanaldehyde, right, propanaldehyde. Okay, right, so first I will write the 3 carbon, right, 3 carbon. Okay, in this aldehyde is there, so this is alpha, this is beta. In the alpha there is a CH3 is there. Okay, clear. Then we go for the second one, that is butanol, right, so butanol. So this is your butanol. Okay, in this third position OH is there. Okay, this is second. When it comes to third one, cyclopentane carbaldehyde. Okay, second item, cyclopentane, we should write it. So this is cyclopentane. In that carbaldehyde is there, means CHO should be there, right? CHO should be there. Okay, CHO should be there. So CHO I am putting. Second position hydrox is there, so 1, 2, second position OH. So this side also we can keep it, that is not a issue. Okay, then 4-oxopentanal, so pentanal, pi carbon, right, so 4 carbon, so this is pentanal. In that fourth position oxo is there, so 1, 2, 3, 4, so fourth position is oxo is there. Okay, then when it comes to the fifth and sixth compound, okay, I will explain to you what they are asking. Disecondary butyl, right, disecondary butyl ketone. Okay, so first we should write the ketone. Okay, secondary butyl we know, right, so this is your secondary butyl, this is your secondary butyl. So if you are not able to write your bond line formula, go and watch the 11th standard video. Okay, then we go for the 4-fluoroacetophenone. First we should write the acetophenone. So this is phenone, this is phenone. Okay, this is acetophenone. In that fourth position fluorine is there. Clear? This is the sixth compound molecule. Okay, clear? Right. Next we go for the preparation of aldehyde ketone. Some important methods which is given here. The first one is oxidation of alcohol. I already told you. If I am taking the primary alcohol, it is going to give the aldehyde. If I am taking the secondary alcohol, it is going to give the ketone. But tertiary alcohol will not undergo the oxidation. Instead, there is a breaking of molecule take place. Okay, if I am using the strong oxidation agent, breaking and acid going to be formed directly. In case of dehydrogenation reaction, I already told you the primary alcohol aldehyde, secondary alcohol ketone. So in primary as well as secondary, there is a dehydrogenation take place. But in case if I am taking the tertiary alcohol, react with copper 573 Kelvin, at the time there is a formation of isobutylene formation because of here the reaction is dehydration because this is your tertiary alcohol undergo the dehydration, but primary secondary alcohol undergo the dehydrogenation. Okay, dehydrogenation. What is dehydrogenation? Removal of hydrogen. What is dehydration? Removal of water molecule. Okay, so next there is a ozonolysis given. So like here, if I am taking like this, it is going to break. Okay, both side oxygen you can add. At the time you are able to get it like this double bond O hydrogen. So this side also double bond O hydrogen. So two altogether. So wherever the double bond is there, break, and both side you can add the one oxygen. Okay, so that is ozonolysis. I will stop here. We will resume next video from the next topic. Okay, thank you. Any doubt, it's there, just comment it. Okay.